Hi everyone, in this video we'll be discussing the problem Boolean parenthesis. Previously this problem has been asked in a lot of companies. Let us quickly read the problem statement and then we'll try to see how we can solve this particular problem. So in this particular problem, you will be given a Boolean expression S. So you'll be given a Boolean expression in the form of a string which will be of length n, and basically true will be given, false will be given, so TF will be given, and other expressions like and will be given, or will be given, and XOR will also be given to you. So just in case if you don't know, then I'll quickly like to highlight that what does the Boolean expression actually mean, right? So in this case, like if you have and, so whenever you are doing and, so both the operators should be true. When you have true and true, then only you get true. If you do true and false, then you get false. If you do false and true, then you get false, and then if you do false and false, then also you get false, right? So I hope that this basic part is clear. So basically if you have true and true will give me true, okay, then false and true will give me false, then after that true and false will give me false, and then false and false will also give me false. So I hope that this basic part is clear. Now going forward, if you will see about OR operator, so in OR, if either of them is true, then the result would be true. So if true or true, then the result will be true. True or false would be true, okay, then false or with true will be true, then false or with false will be false here, okay. Then after that there is another operator, that is XOR operator, that you can see here. In XOR operator, what happens is basically if you are doing true XOR true, then you are going to get what? False here, okay. So if both the operator, if the both are same, then you are going to get false. So false XOR with false will also give me false. Then true XOR with false will give me what? It will give me true. If both are different, then I'll get true. Then what happens? False XOR true will give me basically here true, okay. So these things are there. Now if you will see here, right, so in this particular case you will be given an expression and you have to tell that how many ways are there in which you can get that expression as true. So suppose that the string is given as TTFT, okay. Suppose that the string is what, like you have got T, then you have got T, then you have got F, then you have got T, and let me see the other expression. So you have OR and XOR. So you have got OR, you have got AND here, and you have got XOR here, okay. So what can be the circumstances? So one of the ways that we can evaluate this expression is that, suppose that if I break it here, okay, so basically I can do what? I can choose chunks, right? So basically what I can do is, suppose that I can have a iterator on the operators. So suppose that if this is the kth position that I am at, then what I can do is I can break it from here. So the left part will be evaluated, and then I'll say that the right part would be evaluated, and once they are evaluated, then the kth symbol is going to get evaluated. So this is the logic for it, okay. So you can see here that if I evaluate it this way, then another sub problem will arise here, that what you can do is, let's say if in this part also, for the right hand side that I have generated, you can also bifurcate this part. So you can do the parenthesis here, and if you apply the parenthesis here, then the true will be in parenthesis, and then false or true will be in parenthesis, and because of this, true and this expression will also come out to be true. So true and true will be true, and true or true will overall give me true. So this expression will be evaluated as true. So you have to tell how many ways are there. So one of the ways was that I can take true, okay, then I can do or, then I can take true, and then I can do what, like overall this expression will be in this bracket. Then what I can do is I can do and, then false or with true, then I can close the brackets like this. So this is how I can apply the parenthesis. So basically there can be many possible ways for applying this particular logic, okay. There can be many possible ways. So if there can be many possible ways, then which concept comes to your mind? Recursion, right? And if you will see, always the symbols that are there at those points, the bifurcation is going to be done. If you will see, so suppose that if you have an overall string, right, so if you have a string, let's say true and then false and then rest of the things, and then you have false, whatever you have, so wherever you are going to bifurcate, wherever you are going to apply the parenthesis, all those positions are starting from index 1. Why? Because at the 0th index, at the 2th index, the characters are going to be present. So what you will say is that if you're going to break at the kth position, right, so k can be many ways. So k will start, like let's say if you have a left index and a right index, or I or j index, it depends. So you can name it as I or j, like it totally depends on you. You can name it as ij also, right? So basically what will happen is you will say that if I am going to apply the parenthesis as at the position k, right? So at the position k, like if I am going to evaluate that kth operator at the end, then I will apply the parenthesis from where to where? From I index, or from the left index, from I till k minus 1 I will apply the parenthesis, and then from where to where? From k plus 1 till j I will apply the parenthesis, and whatever is the result of that, okay, that will get calculated, because if I am going to apply the parenthesis last at this kth position, then the left hand side is going to be evaluated and the right hand side will also get evaluated, and it will come to me, and then after that I will see what result I will make. But here the thing is that initially what are the parameters that we need to pass here, if you will see. So summarizing this up, you can see that I will have a recursive function in which initially I'll pass the left and the right. Okay, so initially the leftmost will be what? Because if the whole string is given to me, then the leftmost index available would be 0, the rightmost index available would be nothing but n minus 1th index, right? So I'll pass the left and the right, or the I comma j index, whatever you can say that. You can name it as left, right, or you can name it as ij, right? So you will pass this thing, and then you can say that you can start breaking from the 1th position. So if you want to pass, you can pass the position as 1, or basically you can say that position will always be starting from I plus 1. If this is I, this is j, suppose, so k will always start from I plus 1 index. Why? Because if at ith index there is a character, so at I plus 1th there will be a symbol that will be there, right? And then after that, initially what, like I'll also pass that what do I want to evaluate that expression as. What is the reason behind this? Because initially I'll say that the expression that I am going to pass from I to j, what kind of evaluation I want for it. You might say that we always want true for it, but that is not always the case. Why? Because we will initially pass this parameter as true, because from 0 till n minus 1 we want to evaluate this overall expression as true. So you want to see how many ways are there to evaluate this expression from the starting till the end as true. But as we keep on passing, then we'll keep on changing our requirements. Why? Because if you will see here, so the main scenario is that basically suppose that if there is an expression, right, and suppose that if there was an expression and at the kth place you have done the bifurcation, or you have applied the parenthesis, right, before the kth and after the kth, and the operator is XOR operator. Okay, suppose at the kth place you have a XOR operator, and before this you have calculated the result, and after this also you have got the result. Now before this, if you get true, and after this also you get true, so will you get the overall expression as true? No, you will not get the expression as true. Why you will not get it as true? Because true bitwise or with true will give me false, right? So ultimately I won't be able to get the overall expression as true. So that is why I need to always specify that what do I want from the expression that I have passed, right? So that is why you will say that maybe if the left segment is there, so I want to know how many times my left segment will be true. Why I want to know that? Because if the left segment is true, okay, and the right segment, let's say, is false, right, and the kth operator is what? The kth operator is XOR, then it will evaluate the overall expression as true if this is from 0 till n minus 1, right? So that is why always you require what? Always you require that whatever kth operator is there, it is not always necessary that from the left and from the right you always want true. You want to know that because what can happen is, if suppose that at kth operator you had XOR and you had got false, and from the right side you had got true, so this will also be evaluated as true, right? Whereas if you had got false or XOR with false, then you will get false. So you need to understand that whatever expression we are going to pass now, we need to pass the parameter that what do we want that expression to be. Okay, so whether we want to be true or false, because similar case will apply for OR also, because for all or what will happen is, suppose that from the left we are getting false and from the right we are getting true, then also this overall expression would be evaluated as true, right? So that is why whenever we are passing a segment, right, so that we need to pass that what do we expect from it. Do we expect false, or do we expect that expression to be true? Okay, now another thing is that what can happen is, suppose that if I have a certain operator, suppose that if I have the XOR operator, right? If at the kth place I have the XOR operator. So suppose that what can happen is I might want my left to be true and I might want my right to be false. So in that case, I will say that I want to know the number of times that my left will be true, okay, and I also want to know the number of times my right will be false. Why? Because if like if you will see certain circumstances, right? So you might have applied a bracket in a certain way, then there will be a certain number of ways in which you will get the left as true. Suppose that there are 3 different ways of applying parenthesis such that you can get the left as true, and there are 2 different ways in which you can get the right as false. Okay, then what will happen? Then matching will happen. Now this true can go with this can go with this, right? Basically I'm talking about Boolean expressions, right? You can like basically I'm talking about the parenthesis part, that you might get the first true by applying parenthesis in a particular way, and it will basically it can be matched with by applying the parenthesis on the right side to get false in certain way. That is, let's say first false that I get, it will apply the Boolean parenthesis in a certain way. The second false that I get, it will apply in a certain way. So that will be a different combination. Similarly, the second true also will have with this false and this false, and the third true will have with this false and this particular false. So total number of ways would be 6, right? So that is why whatever you are getting from the left and whatever you're getting from the right, so total combination, basically if you'll see how many times we got the right as true and the left as false for the XOR operator, it depends on the operator. So whatever that was in the answer, we added what if the operator was, let's say XOR, then we did left true into the right false. Okay, another thing can be that how many times the left is coming out to be false and the right is coming out to be true. Okay, so that is for the XOR operator. Whenever you have XOR operator, then you will want what? The total number of ways that you can get true is that left is true, right is false. So left, the number of times the left is true into the number of times the right is false, plus what? Plus the number of times the left is false into the number of times the right is true. And if suppose that the operator is AND, then you will say that in the answer both should be true, so you will add left true into right true. The number of ways that you can apply parenthesis such that you can get the left part as true and the right part as true. Okay, because in AND both should be true, so you will check this condition. If you have the OR operator, then you will say that answer plus is equal to what? Basically the number of ways in which left can be false into the right true, because if any of them is true, then it will be true, no? Then another way could be that my left is true into my right being false, plus another way could be that left is also true into the right is also true. So these are the ways, total ways that are there, right? So I hope that you have understood this particular concept, that we are using recursion and how we are also requiring that whatever segment we have currently from I to j, we want to know whether we want to evaluate it as true or false. It is not always necessary that we might want to evaluate it as true. So now let us look at the code and see what is the approach for this particular question. So what I will do is I'll quickly try to move this to the editor and let us discuss this particular problem here. Okay, so what you can see here is I'll quickly open this. So if you will see, firstly, this will be a dynamic programming problem because there will be a lot of overlapping sub problems since I'm using recursion. And what are the states that will be changing? Basically there will be 3 states that will be changing, that is ith index, the jth index, right? That is the left and the right, and also the parameter that is there, that is true, false, or you can say 0, 1. So that will also be changing. So I need to keep a track of 3 parameters, right? So that is why I'll declare a 3D DP which will be of n cross n cross 2 size, right? So it will be a n squared DP in nature. Then after that I'll call the solve function from 0 as the ith index, and the right index or the jth index would be n minus 1. Then I'll initially say that I want to evaluate that expression as what? True. So I'll pass 1. Then I'll pass the string, and then I'll also pass the DP. Now what happens is that in this particular solve function, what I will do is I will first of all check that, suppose that if I and j are here, right? So I is indicating the left part, j is indicating the right portion, rightmost point. So suppose that they cross each other, since I am always converging the difference between them, because whenever I bifurcate, then they come closer to each other, so they might cross. If they cross, then I'll say that there is no way, and I would return 0 here. Otherwise, what I need to say is that suppose that if I becomes equal to j. So if I is equal to j, what does that mean? If I becomes equal to j, this means that there is an expression of this kind. Suppose that if I did what? If there was an AND operator here and this was the kth place, and suppose that here what I had was, let me just change it. Suppose that if this was true and I had bifurcated it here, then I will be here also and J will be here also. If this is the division point that I'm having, then there will be only one operator, right? So if suppose that what I expected was, so it depends on my expectation. Whenever I get true, then I'll not return 1, because if I expected the expression to be true and I have the single operator as true, then I will return 1. Otherwise, if I expected true and I'm getting false, then I'll return 0. Okay, because if I expected true, suppose that I am getting individual character, right? So I expected that it should be true, and if it is true, then I'll return 1. Otherwise, I'll return 0. Okay, similarly, suppose that if I expected it to be what? If I expected it to be false, okay, if I expected it to be false and it is false, then I will say that I'll return true. Otherwise, if I expected it to be false but it is true, then I'll return 0. So these are the cases, base cases that we need to handle. So let's look at the code again. So yes, you can see that if I expected true and I'm getting a true, then I'll return 1 at that point. Otherwise, if I expected a true and I'm getting a false there, then I'll return 0. This part will return 0. Similarly, in the else case, you can say that if I expected the false and I'm getting a false, then I'll return 1. Otherwise, I'll return 0. Otherwise, I'll check if this DP state is already calculated, then I'll directly return the calculated state, because if a problem is already calculated, then I would not like to calculate it back again. After this, what you will do is you can say that you can start your kth index, or I have written it as ind, from the I plus 1th, and you can run it till j minus 1, and always you will keep on moving it by 2, because if the operator is present at a particular index, then after 2 indexes it is going to repeat. So what I will say is that the total number of ways will be, like, if suppose that the ind index at which I am bifurcating, at which I am going to separate into two parts, that is the left half and the right half. Left half from I to k minus 1 and right half from k plus 1 till r. So there will be requirement of passing the number of ways that I want my left to be true. So I'm passing left. So I will say that I'll bifurcate it from I till index minus 1 and I want it to be true. Okay, then I want to know the number of times it will be false also. So I'll pass the left range as I comma index ind minus 1 and I'll pass 0. So I'll evaluate how many times the left can be false. Then I'll also evaluate how many times the right can be true from index plus 1 till j, and I'll also evaluate the number of times the right can be false from index plus 1 till j, and I'll pass the parameter as 0 because I want to evaluate how many times it is false. So if the index at which I am going to bifurcate into the left half and the right half, okay, if it is and, then I will have to check. So if the symbol is and, I need to check this, right? So if suppose that the symbol is what? Symbol is basically and. So this means what? That suppose that if the ith symbol is there and the ith symbol is and, if the ith symbol is and my requirement is true, that I want that expression to be true, then in that case what will be the number of ways? The number of ways will be nothing but left true into right true, because if the expression is and I require a true, then the number of ways will be nothing but left true into right true. Else what I can say is that otherwise if the symbol is and, okay, else you can say that if the symbol is and your requirement is for false, okay, you require false, then how many ways can be there? So if you require false, then in that case you can say that since it is and operator, then you will want then the number of total ways will be nothing but the ways in which the left can be true and the right can be false, plus what? Plus you can say that the number of ways in which the left is false into the number of ways that the right is true, okay, because this will also evaluate as false, and if I have a requirement of false, right, so I'll count the number of ways that I'll get false using the and operator. Then another way would be what? Another way would be nothing but the number of ways in which you can say that my left will be false into right will be false as well. So if the symbol is and if I require true, then the number of ways will be the left true into right true, okay. Otherwise if the symbol is and I want false, then these will be the three cases in which I need to add. Okay, so this will get me the possibilities. Otherwise, if suppose that the ith symbol is what, guys? If suppose that the ith symbol is basically nothing but, let's say, the or operator. So if it is or operator, and what happens is my requirement is for true. So if my requirement is for true, then I'll say that the answer will be, or the number of ways you can say will be nothing but if the left is true into the right being false, okay, plus the left being false into the right being true, okay, plus what? Left true into right true as well, okay. So if the index that at which I am bifurcating, if it is or and the requirement is for true, then these are the ways that I can get true. Otherwise, if the symbol is what else, if the symbol is, if the symbol at the current kth index or the IND index at which I am bifurcating, if it is OR and my requirement is for false, then how can I get false? I can get false, the number of ways will be the total number of ways in which my left would be false and my right would also give me false. Okay, now the last thing is that suppose if my ith symbol is what, guys? If my ith symbol is nothing but XOR. If it is XOR and my requirement is for what? If the index at which like I want to calculate the last time, right? So S of index I should write, not the ith index. If the S of index is basically and my requirement is for what? My requirement is for, let's say, true here. Okay, then in that case, the total number of ways would be what? The number of ways in which the left can be true into the right can be false, plus left can be false into the right can be true. So this is the case. Otherwise, suppose that if the symbol else if, you can say else if the S of index is what? If else if the S of index is basically equal to XOR and my requirement is for what? My requirement is for false. Let's say if my requirement is for false, then how many ways I can evaluate it? It will be nothing but the total number of ways will be nothing but, you can say as the number of ways in which the left is true into the right is true, because if both are true then it will evaluate as false. If I'm having the XOR operator plus what? The number of ways in which the left is false into the right is false as well. Okay, so these are the ways. So that is what I have done in my code. Also you can see that if and symbol is there and I'm having true, then it will be left true into right true, and I have taken modulus appropriately to keep everything under consideration. And before returning the answer, that is the total number of ways, so I will also check, I'll also store it in the DP so that next time I don't have to calculate it back again, and this will save a lot of computation. Talking about the time complexity of this problem, so basically if you will see, so in every recursive call, in one recursion call, there is an order of n loop that is running. Okay, since in one recursive call there is an order of n loop that is running, so there are n square different recursive calls that will happen. So the overall complexity of the code would be n cube in nature. So the time complexity of my code would be order of n cube, and the space complexity would be what? It would be order of n square. Why? Because of the simple reason that I am going to use a array of n cross 2 dimension, which is basically n square in nature. So that is the way that we can solve this problem. If you would like to see which companies have asked this particular problem, so you can see that this problem has been asked previously in Amazon, Microsoft, Intuit, and LinkedIn as well. So I hope that you were pretty much clear with this particular problem. Just in case if you understood this problem clearly, so make sure to give me a +1 in the chat, comment down understood as well, and make sure to hit the like button as well. Thank you guys.